Today's lecture is about right triangles. So a right triangle is a triangle with a right angle, right? So here, this angle here is a right angle. So we're only dealing with triangles that has a right angle. And we say if a triangle has a right angle, then we have some formula. We have a formula. The Pythagorean theorem says that x squared plus y squared is equal to c squared. For the length square, in this case x squared plus this length square is equal to 5 squared. 5 is considered the hypotenuse. Oh, stop it. All right. So the 5 is the C. All right. So you always have to know the hypotenuse. The hypotenuse is opposite of the right angle. Right. So the side that is opposite from the right angle is considered the hypotenuse, and that's what the C is. Right. So one leg square plus the other leg square is equal to the hypotenuse. So if you want to solve this, find the missing side here. If you want to find the value of x, then since you know that 5 is the hypotenuse, then you would just say x squared plus 4 squared is equal to 5 squared. Right? So once you identify the hypotenuse, it should be straightforward. And so you just solve this, right? So x squared plus 16 is equal to 25. So now you subtract 16 from both sides. So you end up with x squared is equal to 9. So x squared is 9. So therefore now you have to take the square root of both sides, because the square root cancels the square. And then the number that doesn't have the square get plus or minus. So this would say then that x is equal to plus or minus 3. But of course, we are dealing with length, so you cannot have a negative length. So we're just going to say, we're going to reject the negative and just say x is equal to 3. So we're saying the length of x is 3. Right? So the point is, you have to memorize the formula, x squared plus y squared equals to c squared, where c is the hypotenuse. And you can solve any right triangle as long as you have two sides. So here in example 2, we want to solve for x. We are also given two sides. One side is 5 and the other is 12, and we want to find the hypotenuse x. How do I know x is the hypotenuse? Well, the right is opposite the right angle. If I draw a line from the right angle, straight is going to touch the x. Right? So the side that opposite the right angle is always the hypotenuse. The other two legs doesn't really matter. So you could say 12 squared plus 5 squared equals to x squared. It doesn't matter which one you put first, whether 5 squared or 12 squared, right? So it doesn't matter. But the hypotenuse does matter. It has to be on one side by itself. So we just solve this the same way. 12 squared is 144 plus 25, and that's equal to x squared. Where 144 and 25 is 169, and that equals to x squared. And so now we say that we take the square root of both sides, and this side get plus or minus, which would say that x is equal to plus or minus 13. But again, you can't have a negative length, so the answer is just going to be x is equal to 13. So that's how you would solve a right triangle if two sides are given. So you could always find a third side in a right triangle if two sides are given. But now, how about an example where only one side is given and an angle? and you're being asked to find a missing side. So notice here we cannot use a squared plus b squared equal to c squared, right? So a squared plus b is same thing. Yeah, I think it's memorized more like a squared plus b squared, right? So it doesn't matter. X squared plus y squared equal to c squared, or a squared plus b squared equals to c squared. And same idea, right? A and b are the length. Above I put x squared. Maybe I was thinking of circles, but same difference, right? All right, so here, the formula I was trying to say doesn't apply here because we do not have two sides, right? You use a squared plus b squared equal to c squared when you have both sides. So we need something else, and so that's where the trig function comes in. That's when we have to use sine, cosine, or tangent. So I do not know if you remember, but cosine of an angle, whenever using sine of an angle, whenever using a right triangle, is always the opposite of the angle over the hypotenuse. Right? And then cosine of the angle, so whichever the angle is, in our case is 30. So we're going to decide which one of these functions to use, right? I'm just listing all three. Cosine is adjacent over hypotenuse. So we still have to know what's the hypotenuse, right? So the side opposite the angle is the hypotenuse. And tangent is equal to opposite over adjacent. All right, so we have to decide now which one of these we are going to use. So it based on what is given. We're given the angle, so this is the angle. And so we do not have what opposite. Opposite of this angle would be this side, right? So that side is not given. So in other words, we're not going to use sine because sine needs opposite over the hypotenuse. We have the hypotenuse, 5 is. So we're not going to use sine here. We're not going to use tangent because tangent is opposite over adjacent, right? So the best function to use between the three would be the cosine. So we can say cosine of the angle. In this case, the angle is 30. Right? So cosine of 30, we need to figure is equal to, cosine of 30 is equal to adjacent. So what's adjacent to this angle? Adjacent, it would be the side that is touching it, that's not the hypotenuse. So this side is touching the angle, that is not the hypotenuse. So that would be x over the hypotenuse, which is 5, right? Cosine is adjacent over hypotenuse. So we just have to solve this for x and we are done. So we can just now multiply both sides by 5. We cancel the 5 in the denominator here. And so what we have is 5 times cosine 30 is equal to x. And then all you have to do is to put this in the calculator and you are done. So let me get the calculator. Or we know that if you don't want to use the calculator, we know that cosine 30 is what again, adjacent over hypotenuse. So cosine 30 is square root of 3 over 2. Right? So you could put this in the calculator instead, or you could just put 5 times cosine 30. I think it's better if you put 5 times cosine 30. So let me try that. 5 times cosine 30 degrees. And what I get is 4.33. So this would say x is equals to 4.33. Mm. So double check whether you want to put cosine 30 or 5 times the square root of 3/2 should produce the same answer. So the x value here is 4.32. All right, so again, we have to use the trig function when we're given less than 2 sides. Or if we're given, once you have a side and an angle, you could always use one of the trig function. So you have to memorize them. Now, easy way to memorize is SOHCAHTOA. So sine is so for opposite over hypotenuse, and cosine is for ka, so ka, toa, tangent, opposite over adjacent. And if you want to memorize it, SOHCAHTOA. All right, so let's look at another example. So this example says, from the top of a building 80 meters tall, the angle of depression to a point on the ground is 30 degrees. Find the distance from the point to the base of the building. All right, so from the top of a building, 80 meters tall. So you have a building that is 80 meters tall. So here's the building. And that building is 80 meters tall, so it is 80. Now, the angle of depression. So the angle of depression is the angle, we draw a straight line. Depression means going down, so this way. Or if you draw the straight line this way, right? So those are angle of depression. All right? So you sort of say opens down, right? Opens down, opens down. So that means referring to this angle here, going down. So the angle of depression is 35. So the angle here is 35 degrees, right? The 80 is the length. Maybe I put the 80 outside. The 80 is the length, the height. And then if you complete the triangle, it says the angle of depression to a point on the ground. So this would be the point on the ground. Find the distance from the point. So find the distance from here to the base of the building. So you want to find this distance. And of course, it's a right triangle, yes? Buildings are always perpendicular to the ground. All right, so we want to find this length. So this is our x. And notice that we are given just one side and one angle. So we have to use a trig function. So we have to decide which trig function we're going to use. So what we have the opposite of the angle and we have adjacent to the angle. So we need something that use opposite and adjacent. So which trig function is opposite and adjacent? Tangent, right? Tangent is toa. Tangent of the angle is equal to opposite over adjacent. So we're using tangent here because this side here is opposite the 35 degrees and the 80 is adjacent to the 35 degrees. So that means tangent of the angle is 35, is equal to opposite, which is x over 80. So all we have to do is to multiply both sides by 80. So if you multiply this side by 80 and this side by 80, this 80 get canceled. And so what you have is 80 times tangent 35 is equal to x. So you just put this in your calculator and you are done. So I'm going to try that again. put it in my calculator. So I need 80 times tangent 35. And what I get is 56.02 if you round it off, or 56.0166. So we write this as 56. It didn't say what decimal to round it off to, so I'm going to choose round it off to 0.02. So the length or the distance from the point to the building is 56.02 meters, right? So that is in meters. So maybe I should write it here. 56.02 meters. All right, let's try one more. So now this example is talking about angle of elevation. So if the angle of elevation from a point on the ground, so elevation, you're elevating, so your angle is opening up or up. So here you draw this horizontal line and then you draw angle goes going up, right? So that's the angle of elevation. So if the angle of elevation from a point on the ground, so here's the point on the ground, and I assume we need the ground, so here's the ground, right? And here's the point. So if the angle of elevation from a point on the ground to the top of a building is 30 degrees, so if I draw this and saying that this angle is 30 degrees, and then we have a building over here to the top of the building, so here goes the top of the building. And let's do the same thing we did last time. Oops, that's a messed up building, but let's draw that line a little better. All right, so we still have a 90-degree angle here. The building is assumed to be 90-degree angle with the ground. All right, so the angle is 30 degrees, so now we need some length. So, and the point is 50 meters from the base of the building. So this point is 50 meters from the base. So this is the base of the building here. So if you measure from the beginning of the building to the point, that gives you 50 meters. So now we want to find the height of the building. So this would be the height x. All right, so same idea. We have to use a trig function because we only have one side and one angle. So we have to decide what trig function do we have. So again, what do we have? X is what? Opposite to the 30, right? So we need opposite, and 50 is what? Adjacent to the 30. So we need something that involve opposite and adjacent. And again, that would be tangent. So we're going to use tangent of the angle is equal to the side opposite the angle over the side that is adjacent to the angle. So all we have to do is multiply by 50 again and cancel here. And so what we do, we get 50 times tangent 30 is equal to x. So now you put this in the calculator and let me try again. So we have 50 times tangent 30. And what I get is 28.87 if I round it off. So we get 28.87 meters, right? 28.87 meters. And so that would be the height of the building. All right, so those are my examples. So now you get to try a few. So here are some that you can try. And you could check your answer with these and see if you get the same answer.